You ever have one of those moments, you change one little piece of your code, and then something totally unrelated, way over on the other side of your script, mysteriously changes right along with it? It feels like there's a ghost in the machine. Today, we are ghost hunting. We're diving into one of Python's trickiest illusions, the difference between a real copy and a sneaky imposter.
So, this whole thing starts with a programmer. We'll call him Timothy. He was completely stumped by his code. He walks into his colleague Margaret's office looking all pale and confused and says this exact line. He was dead serious, convinced his program was actually haunted. Let's take a look at what he was dealing with.
All right, so what was this ghost that had Timothy so worked up? Let's pull up the exact piece of code that was causing all this phantom behavior.
Okay, so look at what Timothy was trying to do. His logic seems totally sound, right? He's got this official underscore bracket for a tournament. He wants to run some tests, so he makes what he thinks is a totally separate copy called practice underscore bracket. And he uses a pretty standard method to do it, a list slice, that little colon inside the brackets. His goal was super simple, mess around with the practice version without ever touching the original. Seems safe enough.
But here's where it gets spooky. When he printed out both lists, the change he made to the practice bracket had somehow ghosted its way into the official one. Alex was replaced by Timothy in both lists. And remember, he never ever directly told the code to change the official bracket. And that right there is the heart of the mystery.
So this brings us to the big question. How is this even possible? Is this some weird bug in Python? Or is there something much deeper going on with how Python thinks about and handles our data? This is the puzzle we need to solve.
Well, the truth is, this isn't a ghost, and it's not a bug. It's a really fundamental concept in programming that we'll call the shallow copy trap. And let me tell you, understanding this is absolutely crucial if you want to write code that behaves the way you expect it to.
Here's the key. When Timothy used that slice, the colon, he created what's known as a shallow copy. Now, what does that mean? It means Python made a new list, a new top layer. But, and this is the important part, the things inside that list, those smaller lists with the names, they weren't copied at all. Instead, the new practice list just got pointers or references to the exact same inner lists from the original.
Timothy's mentor, Margaret, she came up with this brilliant analogy to explain it. Making a shallow copy of something like this, it's like you thought you were photocopying a stack of documents, but what you actually did was just photocopy a page with their addresses on it. You've got a new piece of paper, yeah, but it points to all the same old houses.
Let's really hammer that home. Think of the official bracket and the practice bracket as two separate address books. But the first address in both books points to the exact same house in your computer's memory. So if you use one of those address books to go to that house and, repaint the front door, that change is going to be visible no matter which address book you use to get there. There's only one house.
Now you might be sitting there thinking, wait a minute, I use slicing to copy lists all the time and it works fine. And you're right. For simple, flat lists, just a list of numbers, a list of strings, it works perfectly. The problem, the trap, only shows up when you have lists inside of other lists. That slice only copies the outer container, it doesn't bother with what's nested inside.
Okay, so if a shallow copy is the problem, how do we make a truly independent clone of our data? Well, for that, we need to bring out the big guns. Let's look at the real fix, the deep copy.
This chart lays it all out. A shallow copy is quick, but it shares those inner objects, which, as we've seen, can be super risky. A deep copy, on the other hand, it goes through everything recursively. Every list inside that, every single item, and it creates a brand new, totally independent version of each one. It's a little bit slower, sure, but it's completely safe.
And here's what that solution looks like in practice. The first step, and it's a big one, is you have to import Python's built-in copy module. Then, instead of that slice, you call the function copy.deepCopy. This is you explicitly telling Python, hey, I need you to go through and make a true exhaustive copy of everything here.
And the result? Boom! The ghost is busted. When we change the practice bracket now, the official bracket remains completely untouched. Pristine. Timothy can finally run his simulation safely, knowing his original data is 100% protected. This is the predictable behavior we wanted all along.
Let's go back to Margaret's great analogy. A deep copy doesn't just give you a new address book pointing to the old houses. No, it goes out and it builds brand new, identical houses on a totally different street, and then gives you the new addresses. The two sets of houses are now completely, totally independent.
So, we've faced the ghost, we've found the solution. What's the big takeaway here? Let's boil this all down into a simple cheat sheet that you can actually use in your own code.
This is Margaret's cheat sheet, and honestly, it's pure gold. First, simple assignment, just B equals A. That's not a copy at all. That's just giving the exact same object a second nickname. Then you have the shallow copy, B equals A slicing. That's totally fine for simple, flat lists. But the second you have nested data, lists inside of lists, dictionaries inside of lists, copy.deep copying is the only option that is guaranteed to be safe.
And here's a little pro tip for when you're debugging this stuff yourself. You can use Python's built-in ID function. It gives you the unique memory address for any object. If you check the ID of an inner item in your original and your copy, and they're the same, if that check comes back as true, that's your warning sign. The ghost is still lurking in your code.
And really, that's what it all comes down to. This ghost was never a ghost. It was just a misunderstanding of what our variables were actually pointing to. Once you get the difference between a value, a reference, and a true deep copy, you gain so much more control and predictability in your code.
And that leaves us with one final thought. This behavior isn't just for lists, you know? It applies to dictionaries, to custom objects, to all sorts of complex data structures. So, I'll ask you, what ghosts might be hiding in your code? Are there any of those weird, unexpected bugs you haven't been able to squash? Maybe, just maybe, it's not a ghost at all. It's just a shallow copy in disguise.